And I will now share my screen, my PowerPoint. Okay. Can I also just get a thumbs up that you can see the PowerPoint, or just put it in the chat? I was just basic checking, making sure that. Thank you, Kyle. Appreciate that. Okay, so my session that I'm going to do is on titled Unlocking High Performance Parallel Compute on Azure with Azure Batch. Now, I don't know how many of you have used are familiar with high performance computing. So that's something I would like to delve a little bit into. So a little from the intro. So I'm going to do introduce high performance computing. So before even we go to Azure, I'm just going to spend a little bit of time just talk about high performance computing in general. And then we'll go to how high performance computing is done on Azure. We will then look at some of the high performance services, so from now on I'll call it HPC, some of the HPC services offered by Azure Batch, offered by Azure, and the main key ones are Azure Batch and Azure Cycle Cloud. We will see a little bit of what they do, but we will ultimately delve a bit more into setting up an Azure Batch instance, because that's what I want to focus on today. There is quite a lot to look into in Azure Batch. So for the purposes of this session, I think the description I gave was a bit more content. I will just keep it to provisioning an Azure Batch instance, and then I will leave the .NET console setup for provisioning an Azure Batch instance program via command line as a separate thing, just because we may not have a lot of time. I just want to spend time to make sure I come across in terms of why we need to use high performance computing on Azure. Okay. Let some more in as well. Okay. Oh, sorry. Just a lobby on the lobby. Okay, there we go. All right, so that's the agenda. So just a little bit about myself. So I'm a Gold Microsoft Learn Student Ambassador based in Perth, Australia. I'm a student. I'm actually a PhD student, and my area, which unlike a lot of ambassadors, is actually not in tech. I'm an engineering student, chemical engineering, chemical sciences area. And so in my PhD, one of my research is just on understanding chemical sciences. So that's what the area which I'm based. So my work is on focusing on biofuels. So we're trying to come up with generate biofuels for the purpose of replacing petrol and diesel, which are fossil fuel derived. So that's what we're doing from my research perspective. But part of that work, so generally as a chemist in chemistry, chemical engineering, a lot of our work is done in the lab. But I have been taking in computational chemistry as well. So part of my work has been how can we simulate chemical reactions? And so that is a big area upon which HPC is becoming involved. So on the right, I study, but I also do some work with, I work at what it's called POSI. In Australia, it's a supercomputer. So this supercomputer is based in Perth, where I am. So I work there. And this is what it looks like. It's been covered, of course. We can't see what's inside, but it's called Cetonics. So this is one of the, I think, top 5 most powerful supercomputers in the Southern Hemisphere. So that's the machine we use. And I just put some specs there for you to see, to have a look at technical specifications. You can see, obviously, this is a supercomputer. You can see it has 154 single AMD EPIC GIP64 GPU nodes. So this comes it's a very big piece of supercomputer there. How many cores does it? Do this? How many cores it has? Yeah, 1592 dual AMD. So it has 1592 dual AMD EPIC Milan cores. So it's a big piece of machinery. And so what I hopefully show in this session is why we need to do high performance computing and how Azure enables us to do that. So that's just a little bit about myself and how I'm going into high performance computing. So just a bit of a background as well. So most of us being ambassadors or coming from a tech realm, we've worked with computers. We know that they're efficient at doing tasks. But when it comes to certain scientific tasks, or not just scientific tasks, even things like rendering, 3D rendering. So you have a lot of these movies, have a lot of rendering in the backend. And so there's two terms that I want to bring up across. One is loosely coupled workloads. So rendering is a loosely coupled workload, and this is a term that it can be, so rendering can be split into small tasks and all are run independently from one another. So you can just think of a GPU. It tends to do this kind of work very well. You have a massive, you need to render this massive image. For example, this one, it's a video. You want to render it. So you can just be subdivided into small tasks, pass it to a GPU, and that GPU can do this work for you. It's subdivided. These tasks don't need to talk to each other. That's what we call a loosely coupled workload. There's another one called a tightly coupled workload. Now, this is where all those small tasks need to talk to each other. That is where the challenge comes, and this is where compute becomes a challenge. So for me, like I have my own custom built PC. It's pretty well spec'd, but it has a limit. So it's only of a certain size. You can get more compute. You can build maybe a machine which has more compute, more cores, a CPU which has more cores. But if you want to scale to the level of doing some of these workloads, there's only up to a certain number of core count you can get. So, for example, 128 on Azure, you can see 128 is the typical core count you can get for a VM. But if your machine want to have 1,000 cores running to do a particular job, then we have a problem because one core can only be on 28, so you need other VMs. But now these VMs need to talk to each other because these jobs that they do, they need to be able to communicate with each other. And this is what we call a tightly coupled workload. Is that this VM is doing this job, this other VM is doing this job, but they need to talk to each other, make sure that they can communicate, and the output, for example, of a particular job can be used on another job. And whenever we do tightly coupled workloads, there's something called MPI, which is a message passing interface. And this is a protocol that enables communication between nodes. And so this is where the challenge comes, because this MPI, the communication needs to be very fast. So if you have two VMs working independently, the interconnect between them tends not to be good enough. So for a supercomputer, one of the benefits of a supercomputer is that it has very fast interconnect. We'll look at it a bit later. And so that's what is a challenge. So when it comes to, so for example, this is a simulation of water breaking, a dam breaking. So a dam was there and it breaks. That's a CFD simulation, computational fluid dynamics simulation. They use a lot of Navier-Stokes, and if you're familiar with that fluid dynamics part of it, this is a computational chemistry simulation. So this is, if you've done a little bit of chemistry, this is calcium carbonate precipitating. So as it moves from a solid to a liquid, so a liquid to a solid solution, it's a molecular dynamics simulation. So this is typically a tightly coupled workload, and this kind of calculation needs a lot of cores to be able to do. And so that is where we need a lot of compute, but it's not just about having large cores. We need to be able to have these nodes communicate to each other, and that's where MPI becomes a requirement. So my field is computational chemistry, and I can also see a bit of CFD there. So that's the tightly coupled workloads. So when we talk about HPC, when I talk about a node, when I say, so I've been referring to nodes, what do I mean? So a node typically has different things. One of the things it has is compute. So generally that's your core. So if it could be 8 core, 16 core, 64 core, 128 core, that's your processing part. But you need to have networking. So for MPI, you need to have very fast networking. And so Azure uses what they call InfiniBand Connect, which I think it allows you up to 1,000 gigabit. We'll see the speed later, but it's really, really, really fast interconnect. And that's what enables a supercomputer to function, is because all these nodes can communicate with each other at super fast time. We need a parallel file system. Again, you're serving files to a supercomputer. So you need to, these files need to be able to be accessed by the different compute in a particular platform. So it's not a serial where this file is to one machine, but it can be accessed parallelly by the different nodes. So we need a file system for that. We need what we call a scheduler. Now a scheduler is when you run jobs, when you run supercomputing jobs, you need to be able to have a queue system. So for example, not only one person is using a supercomputer, many people are using a supercomputer. So you need to be able to, the supercomputer needs to be able to schedule jobs based on time, based on the number of core required, or based on just priorities. So a scheduler is needed to be able to make sure that the supercomputer is running efficiently at all times. So that is a component needed. And then you need optional accelerators. So oftentimes, if I come from a scientific background, a lot of our code for tightly coupled workloads is written for CPU. So CPU, these are CPU run codes, but you find the best way to accelerate your code is if you can run it for GPU. Now, loosely coupled workloads like video renderers, so if you think even from video editing, those are really well written for GPU code. But for us, we're still working and translating our code from CPU to GPU. So GPU is an accelerator. Azure obviously has that. And you have the FPGAs as well, which are other optional accelerators. There's many others that I haven't listed there, but these are typical accelerators that you'd have to, that would be part of a HPC cluster. So these are the things that would be there. So this I've touched on a little bit on this. So these are the obviously from Azure to the different types of VMs that you can have. But these are your different types of workloads. So depending on the interconnect you require, you can suit certain workloads. So Azure provides different VMs, different clusters for different kind of work. So you need to know what you're working with. So in my case, I'm in the simulation category here. Some people in the rendering, some people in the deep learning AI part. So different compute is suited for different workload. So I work at a supercomputing center, which is on premise. So the challenge for us is then, some of the challenges we face with on-premise infrastructure is just, I mean, even if you own a PC, if you own a computer, it's something you face. One is a capital cost, and two, it's just that the technology advances very fast. So hardware becomes obsolete very quickly. It's fine if our computers are just like one machine, but if you imagine owning a supercomputer and you need to replace all the cores, and we just saw that we have over 1,000 cores on the Setonic supercomputer, it becomes very costly. So Azure provides this kind of computing, high performance compute as a service, and it's to avoid some of these challenges that we face with an on-premise infrastructure. So for us here at Posi, we're actually thinking about leveraging Azure for cloud bursting. So when we can do most of our tasks on premise and then burst the excess task onto Azure. So that's something we're looking at. But these are some of the challenges we face with on-premise infrastructure. And that is why I'm talking about high performance compute on Azure. So I talked a little bit about this. So you need an orchestrator for your workload. So Azure provides Azure Batch and Azure Cycle Cloud. Also, and you have Azure virtual machines as well. So typically, you can scale up depending whether you have a tightly coupled or loosely coupled workload. Virtual machines can be good for you, especially for loosely coupled workloads, because you can just run them fairly independently. Azure Batch is as it says here, that job scheduling and compute management to run parallel high compute batch jobs. This is the technology we're gonna focus on a little bit. Azure Cycle Cloud is more it's more technical. It allows you to run more complex code like CFD code, computational fluid dynamics code, and weather modeling code, but it requires a bit more configuration. That will be our focus for another time, but for now we will focus on Azure Batch. So yeah, this is good. This is actually what I was talking about earlier. So MPI is a interconnect communication platform. So if you have a handful of cores and your job's then it's easy to communicate. You don't need a lot of interconnect. You can just easily run that in a AB virtual machine. However, as you're using more cores, you need to make sure communication is very fast between those cores, and you can see that increases a little bit. More performant VMs up until we have Cray. Now, Cray is a supercomputing infrastructure, and so that can be offered for 100,000 cores is a lot of cores, and that's the kind of work that can be done with supercomputing. So Cray is something Azure offer for purposes of supercomputing. So I thought this was a very good graphic to show what we're trying to talk about here. So I talked about InfiniBand. So I'm just going through the basics and then we'll move on to the demo. InfiniBand is your interconnect between different compute. As you can see, actually I was not right. It's at 1.6 terabits per second per VM, which is extremely fast. And so these VMs, this computer connected by InfiniBand network, that's why they can be able, you can almost treat it as one machine, one computer, because they're just connected with very fast networks. Now, for those who are gamers, or you have a gaming PC, you're familiar with the PCLE lanes, and so which is our GPUs have. Those are not good enough for supercomputing. They're good for us, personal level, but when it comes to supercomputing, you need something markedly faster, and that's where InfiniBand come in to enable you use different VMs as one machine. Yeah. Another thing to note. So generally, you can have HPC based. Obviously, the core can either be at least the more dominant ones is AMD and Intel. Intel have the Xeon processors. AMD have the EPIC. I think this slide's a little bit outdated. I think there's the 4th gen processor. So depends what your workload is, and this matters because you need to compile your code to run for that particular processor. So you need where I work, our code is AMD. So we need to compile our programs to run on AMD EPIC cores. So that is something to consider. Obviously, Microsoft offer both HB, HC series. That means you can do both AMD and Intel Xeon compiled. You can run both Intel or AMD compiled code. Azure Batch, Azure Cycle Cloud. So that's the key difference between the two. So if you look at the Azure Batch here, it just looks much simpler. Azure Cycle Cloud has a bit more. You can cater for hybrid cloud busting, as I talked about, or you can have a cloud native model. However, Azure Batch is purely cloud native, and it's HPC as a service. And this is where I'm saying, because we are starting out, I will just focus on Azure Batch to start us out. And then at a later, I plan to do more events more on the Cycle Cloud part of things. But that requires a bit more technique and expertise and a background from the audience side. So I mentioned earlier about the parts of supercompute. So you need you can see we need to input your files to a particular storage. So we need to have a storage service on Azure. We need to be able to then create a pool, a job, and a task. So a pool will just be a pool of compute nodes. So we specify in Azure how many compute nodes we want. So I don't know if, yeah, that's better. Maybe you can see it. So we specify how many compute nodes we want. That's your pool. And you tell the pool how many jobs you want to do. So you can see this, the thing with Azure Batch is that it scales. It scales for you how many compute nodes you need. So, I mean, you can fix it as 2, or you can set it to auto scale, meaning to say you can have 2 or 40, depending on what your subscription allows. And so you can then have a set of jobs that map to that pool. And then you can then, obviously, once you run a job, you produce data. So before you need input data for the job, you produce output data. So that is where the storage comes in there. And then you can see here we have an application or service. So I just want to get rid of the okay. So we have a application or service. So this, we won't touch on this one this session, but remember I said we use this kind of code for a lot of high performance compute is used for scientific computing. So what Azure actually allows you to do is to download or to upload rather your computational software. So what I put on the description was actually a loosely coupled workload. I put ffmpeg. I don't know if you've used ffmpeg before, but it's a video encoding. So it's a video encoder, command line based video encoder, and so it can do a lot of parallel work. You can encode video in a parallel way quite efficiently, and so that's an application which I plan to do. You can put in there, and so Azure will recognize that and use that to run it on all these compute nodes. You don't have to configure that yourself. Once you configure it as an application or service, it will run it on all the compute nodes. It will install it and run it as you need. So that's the beauty of Azure Batch, which we will be able to see a little bit of a bit later. So yeah, I think I've already touched on this part, Azure Batch, how it works. So I think I would like to do a little bit of a demo, and this is to initialize an Azure Batch instance. I think that one of the beauty for us as a Microsoft, and I realize not all of us here are student ambassadors, so I will talk a little bit about the program at the end. But we get credits, which are monthly credits, which allow us to be able to do things that we may not be able to do on our own student credits that we get. So this is something I want to demonstrate. Before I do it for you, I'll just show you what I'm going to do. So I'm going to create a batch service. So you have different services that create a batch service for you. You know what? I will actually demonstrate this as we go so that we can see it. We can see it live. So just give me a second. Just open up my Azure portal first. Feel free to ask any questions as well if you have. I'd be happy to take them on. Okay, so let me share my screen. Just check the chat. Are there any questions? Okay, yep, no problem. Share screen. All right, this should be on. Sorry. Just sign on to Azure portal. Can I get a thumbs up? You can see my screen. I'm right now on the Azure portal. Okay, let's go back to here. Okay, thank you, Kyle. Appreciate that. Okay, so the first thing we need to do is create an Azure Batch portal. I'll probably zoom in a little bit so you can see. Yep, there we go. So you can actually just go on Marketplace. Do you have? And then we look for Azure Batch Service. So the one that we need is this one. There's different, depending on what you're doing, but this is the one we need, the Azure Batch Service. So actually, on that note, Azure Batch is, so normally on Azure, these different things come at have a cost, but Azure Batch is free. You pay for the compute. You don't pay for the batch service. So remember, the batch service is like an orchestration. It enables you to run a job, but what you don't pay for it, what you will pay for is the compute. So we will see a little bit of that later. So I'll just go in and create a provision an instance. I'll just use that resource group I have. MLS demo. Okay, I think I already have something there. HVC demo. So account name, I can just call it HVC batch. Oh, sorry. I think you must only have that. East US. Oh, I have. So review and create. So location is fine. So you need to attach a storage account because remember, as we saw in the schematic, we need to feed in data. We need to save data that we're going to get. So we can actually select a storage account. I think standard is fine. General purpose, that's okay. Yeah. Authentication, storage keys is fine. But if you're going to have this online for production, you need a batch account managed identity. So that's something we need to be mindful of. So for this purpose of our demo, just leave all that as default. We will move on. Identity type, authentication, we have 3 types of authentication selected, no problem there. Networking, if you want, you can create a virtual network and be able to do a bit of networking there. For now, we don't need to worry too much about that. Tags, not needed at this point. So we should be able to create our job. Yep, so validation pass, we should be able to do the create there. So that will create. In the meantime, as that's going in the background, so that's how you make one. I may just, depending on how long that takes, I may just jump onto one that I already made as a batch service. So that's how you provision a batch service. So if I go home, I think I already have a batch service here. So this is a separate one I provisioned. So this is how it looks like. And you can see typically on Azure, if you've made a service before, this the typical settings. You have an overview, so it shows you different parts of your resources. You can see your CPUs, so it shows you 12 tasks. So I will show you how to make these tasks, but you have different tasks. You can be able to see a dashboard. So what I want to point you to is this part. So remember, I talked about applications. So here is where you would put your application. So you can see I've done this prior. So I've installed ffmpeg. ffmpeg is a video encode software. So this is installed on Batch. So what this means that every node that I'll generate with Azure Batch, I don't have to install this software on that node because it is already gonna run automatically. So as long as I uploaded it on Azure Batch here, you can see you can take over 200 applications. So I do some computational chemistry software. You can put that here as well. So that's something we're gonna have there. Pools. So pools I remember pools is your nodes. Pools is your compute nodes that you're gonna have. So we don't have any pools. I'm gonna create a pool first, and then I will create a job. So to create a pool, we need a pool ID. Pool. Can I use underscore here? I think it's fine. Test pool. Identity is okay, it's none. So for your pool, basically you're setting a VM, like setting a VM, you need to pick up an image. So here I need to just go back to this. I will share the slide here and show you some of the pool selections that you can take before I carry on with the demo. So I find my slides. There we go. So, but we've already made a batch service, and we selected a storage account. So in this case, you just need to link your batch service to a storage account. These are your typical settings, which we've done. Storage key, done that as well. So we have our batch account. Our deployment was complete. So what I want to come here is pull just to show you some of the settings. So we need so in this case, for this particular demo that I'm going to do, I'm going to use a Windows image. So typically, actually, a lot of supercomputers, almost 99% run on Linux, because just from a licensing point, Windows requires a license. So from a cost saving, and people tend to use Linux. But for this demo, I'll use a Windows server. I will use a 2019 data center there. This encryption, we don't need to touch much of that. And then I will specify the nodes. So here's where I specify the number of nodes. In this case, they put 2, and you can choose whether it's fixed or auto scale. Oh, sorry. First, also you can select your VM. So it depends on what VM you want. Actually, I will show you what levels of VMs you have, but you can then pick your scale. So I just wanted to walk you through that part. I will go back now to my Azure portal. So here's where the other pool. So publisher is Windows Server. SKU is, I think we're in 2019 data center. Oh, no, I don't remember. I think it was a core small disk. I think data center small disk. I'll just verify that. Core small disk, correct. Data center core small disk. Yep, the one you need to pick. That's just your image that you're going to use. Security type is standard, no problem. We don't really need to change too much for this demo. This, of course, if you're doing for production, you need to configure some of these settings. I just want to go ahead and pick a VM. So you can see, and this is what I was talking about. I mean, you can pick up 48 vCPU is pretty massive, 384 gigs of memory. That's relatively massive piece of a core. I think you have 96 as well. I don't know if they have anything more than 100. But there's some pretty massive cores. But for demo purposes, I'll just leave it to something simple. Otherwise, I'll get charged a ton if I run those big, heavy CPUs. So I'll just pick my VM size as that. Now this is where you can pick if you want your nodes to scale or be fixed. So I'm gonna just have two nodes, and so you can, if you pick auto scale, it'll start with you just need to set some how should it scale. So that's something you can set later. I'll just pick a fixed node. There's what we call spot node. So this is for costing. So VM, I don't know if maybe you've used spot VMs before, but generally if you spot VMs are good because it's on demand and you can probably save around 90% of your cost, Azure cost, if you know how to get the spot nodes. So you can set that up as well if you want. But for now, we want to do that. Optional settings as well. What other thing we need to? So for our job, remember I talked about MPI. So you can see what here is called inter-node communication. So this is where we need to specify our internal communication. Because I'm just doing a demo and I'm just going to run a very simple command. We don't need to have internal communication. But when we need internal communication, we need to set up these things in particular. So that is we need to set it from there. Application package, remember I showed you, like you can choose an application style ffmpeg. You can choose that, it'll install it on all your nodes. So that's there. Networking, we're not going to change much on that. So we're going to leave everything as is. We won't touch the networking. And so what we do is we create a pool. A pool is just your, those are nodes. So you can see you're going to have two nodes there. So it's resizing it. So it just needs some time before it provisions it fully. So as that's happening, I will switch out to the last part, which is on the slide. Is I want to show you what's next. So we've set up a pool. So that's okay. I will show you that view later. After you set up a pool, you're able to see the nodes that you have. What we need to do after that is actually have a job. Now, this is the task that you want your nodes to do. So this could be like a compute job. You need to set it up from here. So you need to give it the job ID. You need to tell it what pool you're going to use, and some settings over there as well. And so once you set up a job, you need then to, in that job, what tasks are constituting in that job. So that's going to be the next bit here. So that's the task we're going to run. We're going to run a very simple Windows task, which is just printing out some and variables over there. So that's what we're going to do. Obviously, this is not a very high intensive compute, but this is just for demonstration purposes. I would like to show you that. So that's where we're looking at. So I will go back to the hopefully by now it's provisioned. Oh, it's still resizing. Maybe very fresh. Okay, we're in. So that's our pool. Oh, sorry, I'm on dark mode, so maybe you can't see the colors properly. But this is a heat map. So it actually shows you how your nodes are being used. So if it's really high usage, you'd see it turn red. So that's what the heat map purpose is there. You can see we have two nodes. And remember, each node has two vCPUs, two threads. So that's our 4 vCPUs there. We're not going to auto scale. So for now, we want to do that. So that's our pool. Our pool is well configured, so no problem. So what we need to do now is set up. Also, you want to see your nodes. So these are your compute nodes. So they're still being provisioned, but those are our nodes. So I've only set up 2 nodes. So they're being provisioned. So what I can do now, I can set up a job. So a job constitutes of tasks, as we saw on the slides. So I will give a job ID, job 001. And you need to select what compute you're going to use. So I'm going to use the pool I selected there, pool 001. That's up and going, no problem. We're not going to touch this for now because it's just a very simple job. So our job is set, right? Now, in our job, we need to set up some tasks. So we don't have tasks running yet. So we need to set up some tasks that will be done in this job. Now I will have to go add task. So I'll call it tasks 001. What do we call it? Let's call it test print for now. And here is where you put your command. So now normally, when you remember we install the software package. So when you install it, you need to run the software. So you put a command to run to call the program, fill in the input files that you need, and remember your files are stored in storage somewhere. And so then you run the command here. So the command I'm gonna run, like I said, It's a pretty simple command. Let me just find it. So I'm gonna run this command here. Just here. It just spits out a standard error, some output files, which just to see that our node's running. So that's the command we're gonna run. Not to worry too much about this. What I want to point out to is MPI. I touched on MPI earlier. MPI allows for the inter-node communication. Remember, we didn't take that option, so I left it blank because this job is simple. We don't need it to communicate with other nodes. So that's the task we're going to run. What else do I need to set? I think I have everything. I've set up the nodes. I've set up the pool. I've set up the job. I've set up the task. So it's going to run. If you had an application, we don't have an application at this point. I'll leave that for another event session, but we're just going to run this command. So I think we're ready to submit. We don't have any other thing that I need to worry about. Resource files. Nope, we're not using any input files as much as we have storage. So let's see. I will run the job. Yeah, that's everything. So let's submit this job. So once I submit a job, if I go to, you can see that it's running. So active, it's been submitted to the nodes. The nodes are running the job. It's not a complicated job. If you notice the command, it ran for 90 seconds because it's the 90-second timer. So it needs 90 seconds for the job to complete. But we can see that, where is our CPU? Let's see if we can look at our CPUs. So that's our pool. So our nodes, you can see it's greenish, meaning it was blue previously. It's doing something. So there's some activity happening there. So I will go back to our, oops, sorry, went too far back. I will go back to our job. Sorry, am I on the right one? Yep, cool. So that's there. Let's see, where's the jobs? Oh, the job's already finished, I think. That's why I can't see it. Yeah. Sorry, I'm just looking for the tasks bit. Just a second. Where is the tasks? There's the jobs. Is that this? Yep, that is the. Okay, just a second. Let me find the. Where are my tasks? HPC batch pools, correct. I think the job's finished. That's why I can't see it. But I just want to show you the results. That's all. Which is like the point of all this. So we really need to see the results. Okay, so let's see. No, it's fine. No problem there. Okay. I'm just looking for. Okay, just a second. Let me go to the slides. I just need to find the task part. Okay. Don't jump. Yep, we've done that. We've done this all. So my first task. Yep. All right. Okay. Oh, no, I think that's different task, obviously. Yep, the application is there. Pools there. Properties is there. Okay, I'll just show you the slides while I find the while I find the I will find, just for interest of time. So what you've done is, this is basically what you've done. The command we run, so it does this for 90 seconds, which it has. You get an output file like this, which I need to find it. For some reason I can't see it, but you would get a standard error text. So if you've done a bit of if you work with the command line, you produce a standard out, which is your text, and your standard error, which is your any error, any errors, anything that was fed produced by the terminal. So your standard out should contain the files that should contain the output of the result, which I think is actually the last slide I have here. Oh, there we go. I did include it. So that's what the command produces. If you open the standard out text, you see it was just producing some environment variables, and you can see it was a simple job, but it was run on the nodes. We didn't. The thing is, Azure Batch has done all this for us. We didn't have to do anything like tell the individual nodes what to do. So this is a simple task, but it can actually do some much more complicated things. So that's what I wanted to show. Let me just give one more a minute or so. Let me see if I can find. I really want to show you what our result. Okay, I think let me just create another job 002. I'm not going to run it. I just want to see where the job loads. So job 002 is there. Okay, I will just, interest of time, I will just leave it at that. That is the first demo. So what I wanted to show you was that we can use Azure is very, very well equipped for high performance computing. And there's much more that we can do. My main initial intention was actually develop a .NET console app, which rather than all that we configured via the Azure GUI, but we can actually do that via the Azure Cloud Shell command line, which is what I've done. However, I think that precedes, like that is a sequence, that's a follow-up from this event. And so hopefully that gives a little bit of an insight into what HPC does. So for my case, I install computational software as applications, and then I would run those on Azure Batch with maybe 10 pools, 10, 20 nodes. So that's the scale, probably with 16, 18 core count as well. So that's the scale which we try to do things. But currently my student ambassador subscription doesn't allow me to have that level of nodes because it's going to be very expensive, and I will run out of a quota. So it's something we do from a more application point of view, but definitely for demo, definitely for small nodes, we can be able to do that quite okay. So any questions on the chat? Any questions on anything about Azure high performance computing or something I could clarify? I am also mindful that not everyone here is a student ambassador. So I think it would be beneficial to just mention that the student ambassador program, I'm a gold student ambassador. And so I've been an ambassador for 4 years, and it's been a really good learning journey for me because like I mentioned, I come from chemistry, computational chemistry, not so much tech, but being part of this program has really helped me upskill, pick up technological skills, and which will really be beneficial for you, regardless of what career path you take. I would also want to mention that the ambassador program has changed a bit. The application, it used to be an application point of view where you apply via video registration, like you do a proper application, and you get vetted and screened. The selection system has changed. Now it's via registration, so anyone can get into the program, provided you meet certain criteria. Like if provided you accomplish the milestones that they have for you, you are a guarantee into the program. So that's just something for you to think about as well. If you're not an ambassador, you can reach out to me, or you can just type in Microsoft Ambassador and how to apply, and you give you some steps on how to do that. So it's a wonderful program, and we get so many benefits. One of which is renewing Azure credits, which have really enabled me to explore Azure in different ways. So, and cloud skills are really important, whatever job you want to pursue. Certainly for me, even in the chemical sciences area. So, any questions? If not, I will wrap it up there. I will have other ones coming up when I explore Azure Cycle Cloud and I explore Azure Batch, but setting it up from the cloud shell perspective. So if you're interested, you can follow me on my socials, which are already on the event description. I put my LinkedIn there. So if you want to follow my HPC journey as well, that would be good. I think it's good learning for everybody. So yeah, that would be all from me. Thank you for tuning in. I appreciate that. And yeah, enjoy your evening or whatever. It's evening here. I'm from Perth, Australia, but I'm sure you're from different parts of the world. So I hope it was useful for you. Feel free to reach out to me in the ambassador program or otherwise if you need if I could clarify anything. Otherwise, thank you for joining. Thanks, Louis. Thanks, Kyle. Appreciate it. Okay, thank you. I will end session now. Thank you, everyone.